Positions of three towns A, B, and C are shown in the figure below. Got AB is 17 and B is on a bearing of 0, 4, 0 from A, so this angle is 40. BC is 25 and then C is on a bearing of 0, 7, 2 from B. Finally, you choose angle ABC, so that is this one here. Well, we can use our knowledge of parallel lines. When you have this kind of setup where these two are parallel, which they are here because they're both norths, these two angles add up to 180. So the same applies here. This must be 140. And then we can work out B. We can do 140 plus 72 to give 212. So the angle is going to be 360 minus 212, which ends up being 148. Now find the area of ABC. So there's my triangle. And we can use the formula a half AB sine C. Okay, so non-right angled triangle. So I'm just going to relabel it. This is now going to be capital C and this little c, and then I'll call this A and B. Therefore, I'll get a half times 17 times 25 times sine 148. Put that on a calculator. Which gives 112.60. Or to three significant figures, 113. Kilometers squared we could write if we wanted to, but the main thing is the 113. Next up, find the distance AC. Okay, we don't have an angle side pair here, we just have an angle, and then the one opposite is what we want to find, but we've got the other two sides, so we can use the cosine rule here. So I'm going to write c squared is a squared plus b squared minus 2ab cos c. There's other versions of this formulae, but this is the one I'm going to use. You just have to kind of slightly jig it around otherwise, but you'd have to relabel your triangle as well. So for us, we've got AC squared will equal 17 squared plus 25 squared minus 2 times 17 times 25 times cos 148. So that gives 1634.8. And then I just need to square root it. So 40.43. 40.4 kilometers to three significant figures. Now find the bearing of A from C. Okay, I just need to remember that C is actually here, top right. So I've got my north, and I want to work out this angle here. Well, again, we can use co-interior angles. This one here is going to be 108, and I just need this missing angle. I can use the sine rule for this, so let me call this x, then sine x over its opposite side, which is 17, is going to equal sine 148 divided by its opposite sine, which we just worked out, 40.43. Therefore, I can do 17 sine 148 all over 40.43. That gives me sine x. I'll write that down, 0.2228. So x is inverse sine of the answer, which is 12.874. So to get the bearing, I'm going to add that angle onto my 108 and do 360 minus that. So 360 minus 120.87. I've already forgotten what it was. 120.87. Gives us 239.12. Okay, nicely done. Finally, part B, which is completely different, is to try and solve this trig equation. Tan x plus 2 sine x equals 0 between 0 and 360. Well, we've got the trig identity tan x is sine x over cos x. So I think that is a good start here. There's no sine squared plus cos squared as 1 that's like obvious to use. So I'm going to replace tan x by sine x over cos x. So sine x over cos x plus 2 sine x is equal to 0. I'll times through by cos x. And then factorize out sine x. 1 plus 2 cos x. So either this is 0 or this is 0, meaning that cos x equals minus a half. Now, if you happen to see that there's a common factor of sine x and just divide it through at this point, you must also consider sine x equaling 0, otherwise you've missed a solution. That is clearly a solution to this equation. So be careful about cancelling things out when they're functions of x. You have to consider the case where they're also equal to 0. And then we can do inverse sine. We're looking between 0 and 360. Okay, from the graph of sine, it's going to be 0 when x is 0, 180, or 360. Okay, these 3 points here. From a cast diagram, you would actually get a line here and here, and that's how you get your 180 and then your 360. Or cos x is minus a half. Which gives 120. From my cos graph, so we've just found, say, this one here. So the other one is going to be, because of the symmetry of the cos curve, 360 minus 120, so 240. Or cast diagrams, all sausages turn cold, we get, because it was negative, we got this one here, and then we're going to be looking at that one there. So you can see, whilst we had 120 here, we can just do 360 minus 120 to get that other one, that 240. So these are 5 solutions in the range. Well done.